All right, let's get right into it. If you're trying to squeeze every last drop of performance out of your call center, you've probably already looked at the obvious stuff, the hardware, the bandwidth. But today, we're going way deeper. We're going to look at the very heart of your operating system, the Linux kernel.
But first, let's set the scene with a feeling I'm sure is familiar. It's that constant, low-level frustration from tech problems that just never seem to go away.
I mean, does this sound like your typical Tuesday? Calls dropping for no reason, the whole system grinding to a halt right at peak hours, and your agents getting more and more frustrated with the very tools they need to do their jobs? It's a total nightmare for morale, and it's definitely not efficient.
So what's the usual fix? Right, we throw more money at it. We buy bigger servers, we upgrade the internet connection. But what if the problem isn't the hardware at all? What if the real culprit is hiding in plain sight, in a place most people never even think to look? Your system's default kernel settings.
And that brings us to the main character of our story today. It's time to pull back the curtain on the Linux kernel and figure out why it's so incredibly important for your call center's performance.
I love this analogy because it just hits the nail on the head. See, your server's out-of-the-box settings are built to be a reliable family sedan. They're made for general, everyday use. But a high-volume call center? That's not a casual Sunday drive. That's a racetrack, and you need a Formula One car that's been precision-tuned for insane speed and endurance.
So what is the kernel really? The easiest way to think about it is like the central nervous system for your server. It's this core piece of software that manages literally everything: how memory gets used, which tasks get priority, and, most important for us, how all that network traffic flows in and out.
And this really gets to the heart of it, right? We're not talking about some massive, expensive project. We're talking about making small, surgical changes. Just imagine, what if a few tweaks in a configuration file could completely revolutionize how your call center runs?
Okay, so you're probably asking, how do we actually do this? Well, we're not going to leave you hanging. Let's open up the toolkit and look at the 3 main pillars for tuning this thing for performance.
Here's the game plan, and we've broken it down into 3 key steps. First, we're going to tackle the network stack itself. Then, we'll get our hands dirty with a tool called Sysctl to fine-tune some really specific kernel settings. And finally, we'll look at process scheduling, which is all about making sure your live calls get the VIP treatment they deserve.
Let's start with the network stack. So, picture your network data as cars on a highway. The kernel's network buffers are kind of like the on-ramps. If those on-ramps are too short, what happens? You get a massive traffic jam. For us, that means dropped packets, lag, and jitter. By making those buffers bigger, we can create a super smooth, fast-moving flow for all that call data.
Next up, Sysctl. Think of this as the master control panel for your kernel. It gives you direct access to all the important knobs and dials. For example, there's a setting called net.core.somaxcon. By increasing this, you're basically telling the system, hey, it's okay to handle a bigger line of incoming connections. This one little change can be a total game changer and stop calls from dropping when you get a sudden rush of traffic.
And finally, we have process scheduling. You know, not all the tasks running on your server are equally important. What we need to do is tell the kernel, hey, see these processes that are handling live phone calls? They are absolute VIPs. When we give them priority, we make sure they always have the resources they need. And that translates directly into a crystal clear, lag-free call for both your agent and your customer.
All right, theory's one thing, but what does all this tuning actually look like in the real world? Let's check out the kind of results you can really expect to see.
Okay, check this out. This is the metric that keeps call center managers up at night: dropped calls. You can see before any tuning, the number is way up there. But after we apply these kernel tweaks, that number just plummets. We're not talking about a small improvement here. This is a massive, game-changing increase in call stability.
And it's not just about making things more stable. It's about scale. This chart shows how many calls the system can handle at the same time. Before tuning, you hit a pretty clear ceiling. After tuning, that ceiling is completely shattered. You can handle way more traffic on the exact same hardware. That's huge.
But beyond all the charts and numbers, what does this really mean? It means a better day for your agents. When the system just works, they can actually focus on the customer instead of fighting with their computer. It creates this seamless, positive experience for everyone involved.
So we've seen the problem, we've got the solution, and we've seen the incredible results. Let's just bring it all home and talk about what you should remember as you start thinking about your own systems.
So if you remember anything, remember these 3 things.
First, next time you're having performance issues, don't just immediately blame the hardware. Second, understand that the real key to unlocking performance is often hiding deep inside the Linux kernel. And finally, never underestimate the power of small, precise tweaks. They can deliver absolutely massive results.
And that really brings us to the final question, the one for you to think about. After seeing what's possible, you have to ask yourself, is your call center leaving all of this amazing performance just sitting on the table, all because it's tucked away in a few lines of code?